is the second classes lab. For today, we'll be discussing data sets and how to pre-process them, as well as apply data augmentation on the data. The first step is to actually find your data set. There are many places. For this tutorial, we're going to use the data set on kaggle.com. On Kaggle, you can search for many different kinds of data sets. If it prompts you to sign up or log in for an account, you can do that with your Google account, your Gmail account. You can search any data set you like. If you want to find images on cancer, for example, you can type cancer and you can click on the data set option, and then you can select the data set that you want, be it lung cancer, breast cancer, or skin cancer. What we're trying to do is a very simple fruit detection. So I'm going to write fruit images. When fruit images comes up, I have to select data sets. Now I want this one, fruit images for object detection by Mohammed Buyukinaji. So I'm going to click this one, and it will show me that this is a data set. It contains 3 different fruits. I have apple, banana, and orange. And there are also XML files for labeling. I want to download this data set. To download, you click the black button that says download, and then I want to download data set as zip. It also shows the size of the data set. Data sets can range from megabytes to gigabytes. I'm going to download the zip. I'm going to allow, and I'm going to wait for it to finish. So this is the manual way of doing this. If you are struggling to find this data set, or if you can't download it, or you don't want to do this whole process, there is a repo. The link will be shared in the group. You can easily just click on code and then open with GitHub Desktop. When this comes up, it will load it. I have already loaded it in my GitHub Desktop. Once you have cloned it, you can click on Open in Visual Studio Code, and you can continue the steps from there. All of the steps are already outlined, they're already typed. So in opencv_matplotlib, you can go through the steps by yourself, one by one, to see the results. For us, we're going to do it from the beginning so that you can practice typing this code yourself. So I'm going to close GitHub Desktop, and now my archive has completed. It's going to be in Downloads. In Downloads, I have an archive. Inside that archive, I have 2 more folders. I have test zip and train zip. In test zip, I have another folder called test, and then inside there, I have all of my files. This data set has already been processed by the owner for training. That's why it has a train zip and a test zip. This is not what I want exactly. I want to bring all of the current data back to the root folder. So the first step is to bring all of the files up into archive. I will open this in a new window, go into test, and then I will grab everything. To grab everything, you can press Command A on Mac or Control A on Windows, and then just drag and drop into archive. I'm going to sort by kind so that I can see everything. Then I'm going to do the same thing for train zip. I'm going to open in the new window, go into the train folder, select everything, and put it into the archive. Now everything is here. I have these 2 empty folders. I don't need them anymore, so I will select them and delete them. The next step is to check if all of this data is clean. When you are performing data cleaning, you're supposed to check if every image is okay. So technically, you should go through every single image and confirm it is an apple, or it is a banana, or it is an orange. The easiest way is to find the image and then drop it into its corresponding folder. Because we know that in Kaggle, it told us that there are 3 different fruits, apple, banana, and orange, I'll create 3 new folders, apple, banana, and orange. Now I will drag all of the images that are apples into the apple folder, all the images that are bananas into the banana folder, and all the images that I think are oranges into the orange folder. Technically, you should do this one image at a time so that you can confirm what the image is about. However, for this, we know that some of the images are safe, and so we'll just do them, most of them at once. So the first thing to check is that, are they images? And I see that I have XML images and JPG images. I don't want XML images. Those are not image files. So I will sort by kind, and I see that the rest are XML. So I don't want XML files. From where the first XML starts, I am going to Option Shift and then use the arrow key down to select everything. And then I'm going to right click and move to trash. This will get rid of all of the XML files. Now I only have images. I'm going to select the apples from Apple 95, Option Shift up arrow, and then deselect these folders, then drag these into the Apple folder. Now those were the apples. Next, I'll do bananas. So I'm going to go from banana 94 all the way up. Deselect these folders, put it into bananas. And finally, I will take all the oranges and drag them into the orange folder. So all of the images that were supposed to be in the corresponding folders are now in the corresponding folders. However, I have these other images. I have mixed one, which is a banana, an orange, and an apple, and then 3 bananas, 2 oranges, 2 apples, and an orange. This is not part of my data set. This is a mixed version. I do not want this in my data set. So what I will do is I'll take all of the mixed images and I will also move these to trash so that they're not part of my data set. Now I can say that my data set is clean because it contains only the images I want for each subcategory. So when we go back to downloads, I want to rename this archive so I can find it easily. I'm going to call it fruit dataset. This is my dataset. However, I want a workspace to work into Visual Studio Code. There are 2 ways to do this, but I guess the easiest way is to create a new folder and call it practice pre-processing. And I'm going to drag the fruit dataset folder inside of here. Now, I want to go to Visual Studio Code and I want to open that folder. I'm going to go to File, Open Folder, Downloads, Practice Pre-processing. And that will open my workspace. Practice Pre-processing, and it has the folder Fruit Dataset. Now I want to type some Python code so that I can manipulate the dataset. We are currently in the Explore tab on the left side, and I want to create a new file. There's this icon right here that says New File. It is, I guess, the 5th icon from the right, New File. I want to type this as practice.ipynb. The ipynb file is a Jupyter notebook. It is an interactive Python notebook. We can use it to write code step by step so that we can run it to visualize what is happening. To create a new cell block, you can click on the code button. This will let you write Python code. I can type a very simple code instruction. For example, hello, my name is Ibrahim. Because this is text, you have to surround it with the quotations. So it starts with a quotation and it ends with a quotation. Now I want to play. If you do not see this play button, you have to go to extensions and you have to install these 2 extensions. One is called Jupyter, the first one, that is from Microsoft. You can click the install button. The second one is called Python. which is also from Microsoft. You can click the install button. If you do see the play button, click it. It will ask you to install or enable suggested extensions, Python and Jupyter. So it will install both of them together for you. It will also ask me sometimes to verify. So I will click install and then again, install. The next step, it will ask me to select another kernel. It is asking me which environment do I want to go into. If this pop-up does not come, you can activate it from this button over here that says select kernel. This is also how you switch kernels. So I'm going to click it. I'm going to select Python environment, and then I'm using Python 3.9.9. When you select it, it will show that your code is valid by giving it a different color scheme. Currently, this is purple, blue, and black. When I play it now, it might ask me to install some other stuff. If it does, accept. Otherwise, it will run and it will print out the text that you want it to. So now it says, hello, my name is Ibrahim. Printing is a way of seeing what is happening with your code. You can type whatever you want. If you type a number here, I can see 2. If I write arithmetic, it will add the numbers and then give me the result. What we want to do for this lab, we want to see an image and then we want to pre-process it. And then we want to do it as a big batch of images together. So the first thing is to use a library called OpenCV. The first thing when you're trying to use libraries is to install them. To install a library, especially the one we're trying to use for OpenCV, we write a %, which we can find at shift and the number 5. And then we write pip install, and the package name is called OpenCV-Python. There's a second package that we want to install. Let me Control Z. Pip install, and it's called matplotlib. This is used to draw graphs. I'm going to click the play button and it will install both of these packages. It might take a couple of minutes to install, so let it finish. Whenever something finishes correctly, you will see a little tick along with how many seconds it took to run. Now I want to create a new code block. If on the code block you see, and you see code, it will create a code block on top of it. We don't want it to be on top, so I'm going to delete this one. I want it to be below. So I'm going to scroll down and find where it ends, and I'm going to click a new code. I want to read an image. So I'm going to use the imRead function from OpenCV. Because I haven't imported it yet, it tells you imRead is not defined. So I want to define it by importing it from CV2. I will import CV2. Then I'm going to say CV2 dot imRead, and I'm going to specify the path where my image is. My image is in fruit dataset. It's in apple, and I want to select the first image, apple_1.jpg. So the path will be // to denote that I am in my current directory. I want to go to fruit dataset. I want to go into apple, and then I want to select apple_1.jpg. So now I have read this file and I want to save it somewhere. So I'm going to create a variable. I'm going to say this is my image. So my image is currently being saved here, and I can print it out to see what this image looks like. If I play this, I will see that my image is just a set of numbers. Numbers that go from 0 to 255. Currently, they're just all 255. This is my Apple One image. So I can say, when I put a £, images go from 0 to 255 in value. And if I select the first box over here, this one, and I play it, you'll see that there's less output I'm also going to select the first box again, so that I only see this first row. This means that this value is 255, this value is 255, and this value is also 255. By default, this function cv2 imread will always give you your images in a certain mode. It will give you your images in blue, green, and red mode, which in short is BGR. When we try to view this image, you'll see that it does not look like the original. This is currently the original. It is red with a green leaf. So let us view the image using matplotlib. The first thing I need to do is import it. So I'm going to import matplotlib. And the library I want to use is something called pyplot. So rather than writing it this way, I can say from matplotlib, import pyplot. I don't want to print it out anymore. I'm just going to comment this by putting a hashtag before this code. When you put a hashtag before any code or any statement, it will be a comment. A comment will not run, it will just stay there. So I'm going to say pyplot dot im show, and I want to show my image. So I'm going to call the pyplot show function, and I'm going to play it. When I play it, I can see that this is blue, even though it was red. To fix this, you can set the mode, the color map from blue, green, and red to red, green, and blue, which is the default for viewing images. So I'm going to say my image in RGB format is when I go from CV2 and I change the CVT color of my image. So I'm going to say I want to change my image. I want to give it a new color. So the color is from CV2 again, color underscore is going from blue, green, red to red, green, blue. This is what I want. And I want to show my image in RGB. When I play it now, I'll see that this is the correct image I'm trying to view. Just so that we can see both images at the same time, I am going to create a subplot. I want my subplot to have one row. I want it to have two columns, and I want it to be the first. Then I'm going to copy this, paste it there, and I'm going to have the same thing, one row, two columns, but I'm going to select the second column. And for the first one, all I want to do is show my image. And for the second one, I want to show my image in RGB. When we play this now, we can see them side by side. There is a blue image and there is a red image. So this is a way of viewing images. Now we want to perform some kind of pre-processing steps. The first step is simple. It's called grayscaling. It is almost like this code. So I'm going to say, I already have my image. I want to change the color map to gray. I'm going to create a new code block underneath this one. I'm going to say my grayscale equals to cv2 dot cvt color. I'm going to take my image and then I'm going to give it a different color map, which is color underscore. Remember, it goes from BGR to, and this one is going to gray. So this will change my color to gray. Now I want to view it. So same thing. I'm going to take my viewing code and I'm going to place it there. And then I'm going to say pyplot.show. So technically this should work. However, when I play it, you don't see much. It's the same thing. But what is happening? Something is wrong with the grayscale. So I'm going to take my grayscale and replace it here. You'll see that even though this is in BGR mode, this is not grayscale. We have to state that when we're showing this image that we have changed the color map to gray so that it renders correctly. Now you can see that this is gray. This is one of the pre-processing tactics that you can use. Another pre-processing tactic is resizing all of your images. Resizing just means changing the height and the width of your images. These images do have size, as you can see on the graph. They probably have a height of 0 to 300 pixels, 250 pixels, and a width of 0 to 300 pixels. So by just viewing it, I can say that they go from 350 by 300 px. What we're trying to do is we're trying to make them all uniform. So we're going to change them to be 64 by 64. To do this, I'm going to create a new code block. I'm going to do the same thing. I'm going to get my image first and then resize it. The resize package comes from CV2, so CV2 dot resize. I want to resize my RGB image, the one that is already in red, green, and blue. So I'm going to resize my RGB image, and I want to give it a height of 64, comma 64. And I'm going to save it in a variable called resized. Now I want to show it. So it's the same code. I'm going to copy this. I want to show the original image, which is my image RGB. I want to show the resized image, which is resized. This has not been mapped to any other color map, so this is fine. When I play this cell, I can see something has changed. You can see that the axis goes still from 0 to 350 and 0 to 300 for the normal one, but now for the other one, it goes from 0 to 64 and 0 to 64. Along with that, you can see that the quality has changed. You can almost see the pixels as well. If I click this chart button, it will open this in a new tab and you can zoom in and see the differences. This one is smooth. This one is now pixelated. So it is now 64 pixels by 64 pixels. If we were to change this to 10 by 10 and play it, you will be able to count all of these pixels one by one. So when I zoom in, you can count 0. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have resized this from the current dimension to 10 by 10. However, I want to change it back to 64 by 64. So this is resizing. There is also noise reduction. For noise reduction, you have to find an image that has noise that you want to use to be able to denoise. So I'm going to create the code and then find the image. Same steps. It is from CV2. It is called fast NL means denoising colored. And this takes a couple of parameters. It takes the image name. So the image is called my image RGB. And then a matte like, which is currently none. I don't need one. Then the next part is the H color, the hue color, which is commonly 10. The next part is the other color, which is almost 10. The window size, how many pixels it should move. I'm going to keep 7. And the last one is the search window size. The search window size, if it's larger, it will be a little bit slower, but it will do a great job at denoising. If it's smaller, it will be faster. However, it will not do a great job. So I'm going to keep a very small number first. I'm going to keep 55. Now I need to find an image that will work with this. So let me go to Documents. GitHub. I'm going to find preprocessing. I'm going to take this noisy image and I'm going to put it inside of my folder. Now, let me reload the image here. I'm going to call it noisy image. It's in my current directory and it's called noisy.jpeg. Now I need to turn it into RGB, so I am going to call it noisy image RGB. It will take the noise image and change it from BGR to RGB. And then the next step is I want to take the noisy image RGB and apply denoising. I'm going to save this as denoised image. Now I want to do the same steps of showing it. So to show, it's the same code. Just remember to change stuff. So now the original is noisy image RGB, and the second one is denoised image. When I play it and I view it, you can see that the first image has a lot of noise. It has all of these grains, but the second image, it has slowly started to smoothen them out. If you can see this balloon over here, it still has some noise, but in this one, the noise has sort of started to disappear. When you increase this last window size number to something big and you replay it, it will take more time, but it will smoothen it out further so you can have less grain inside of the image. So now you can see sort of it has made more smoother parts of the image. So this is denoising. It is removing noise from an image. Practice is to perform data augmentation. CV2 is an amazing library, but it can be really hard to work with when performing the things that you need to do for data augmentation. What data augmentation is let's say you have 100 images and they're not enough for training. You're trying to get more images, but they're just not available. What data augmentation does is it takes the images that you have and it creates new ones from that set. So what we're going to do is we're going to create more images from the ones that we have so that we have more to train with. The library we're going to use is called Albumentations. They have a website on albumentations.ai. Most of these packages have something called documentation. So when you click at documentation, it will take you to this page. And this page, it has instructions on getting started, how to install it, and some of the core concepts. To install Albumentations, you type pip install Albumentations. So let me just create a new one, call it albumentations.ipynb, so that we have a new place to work with. The first step is to pip install Albumentations. I'm going to play this. I'm going to select this kernel and it will install Albumentations. Okay, so it has installed Albumentations. When you install things inside of the same kernel, you don't have to reinstall them again. In practice, we had already installed OpenCV Python and Matplotlib. So because we are in the same kernel again, we already have access to all of those imports without reinstalling them again. So I'm going to have a new code block, and then I'm going to go back to documentation to see what it says. In pipelines, it shows you what you can do. The first step it says is to import Albumentations as A along with CV2. So I'm going to import Albumentations as A, and I'm also going to import CV2. Next, let me close this and put this side by side. The next step is to create a pipeline. So this pipeline is a transformation. You can compose different transformations, and it has a list. It says that I could make a horizontal flip is when you take what's on the right side and put it on the left, and what's on the left side and put it on the right. Then you have random brightness contrast, which will make it brighter or darker. And then you have Gaussian blur, which has 30% chance to blur. There are many other types of augmentation variables that you can change to, but let's try these three. I'm going to try each one once at a time. There is also a variable that's called P, and P currently is set to 0.5. 0.5 means it has a 50% chance to flip. It may flip or it may not flip. The higher you keep this probability, the higher it will happen. If you keep it at 0, it means it will never happen. If you keep it at 1, it means it has to happen. So let's create a transformation. I'm going to say transformation equals to, and we have to call the compose function. So a dot compose. I have to keep round brackets along with square brackets. And inside here, I'm going to type my transformation. So I have a dot horizontal flip. And remember, we have to have a probability. So we have p equals to, let's say, 0.5. Now, I have to use this transformation. To use this transformation, you can say transformation. I have to say the image that I'm trying to pass in. I don't have my image yet, so let me use CV2 to read it in. CV2 dot imRead. I'm going to get from the current root data set. I want to go into oranges and I'm gonna get any of the oranges. I want to get orange 10. This is gonna be my image. Okay, remember the second step is to change the color. So I'm gonna say my image RGB equals to CV2.cvt color. And then I'm gonna pass my image. And then I'm gonna call CV2 color map. So color BGR to RGB. Now I have my image. I'm going to take it and put it there. My image RGB. The next part is to call the image. And finally, this will give you my transform. So I'm going to call it augmented. This will give you back an image. And now I want to show it. So it's the same code as before. This one, to plot it, I'm just going to copy it because it is quicker. I'm going to go back to augmentations and I'm going to paste it there. Now, pyplot is also not imported. If you see anything with a squiggly line, it means it's not imported. I'm going to import it here. Import matplotlib dot pyplot as pyplot. And that is done. I have to change the names. I have my image RGB, and I need to keep this one into augmented. When I play it, I can see that nothing really happened because I have 0.5 of flipping. So let me try again. Now it worked. So this one was on this side. Now it has flipped it to this side. So 0.5 chance just means that it may flip or it may not flip. If I keep this to 1, it will always flip. No matter how many times I run it, it will always flip. If I keep this to 0, it means it will never flip. It will always stay the same. So this random chance ensures that you have sort of a diversified set inside of your data set. Let us copy the other transformation. I'm going to get the random brightness, and I'm going to keep it inside of this list. To keep a new one, you have to keep a comma first, and then the second one. It's random brightness, contrast, and has a probability of 0.8. This means it will perform both transformations at once, with a probability of this happening 0.5 and this one 0.8. I'm going to play it. It has flipped, but maybe not much contrast. Okay, now it has applied contrast. You can see this one is normal, this one is a lot brighter. So that is random brightness contrast. And then the last one is Gaussian blur. This will blur the image. Let's change this to 1 and this one to 1 so it always happens. And also this one to 1 so it always happens. When I play it and I review it, you can see the image has changed. It's now darker instead of lighter, but you can also see it has also blurred it a little bit. It's not as sharp as it was before. So Gaussian blur will blur the images a little bit, making it a little bit less quality. So this is data augmentation. It just means I'm making a new image from the one that I already have. Now, we already have some code to help you make all this augmentation a little bit easier. It will create a loop that will go through your whole data set and process everything as well as augment everything. These are inside of this repo. If you want to download something specific from the repo, you can click what you want. I want to select the A underscore process dataset.ipynb. Then I want to download it using this download raw file button. And then it should be in my downloads. So I'll go to downloads and I'm inside of practice preprocess. I'm just going to drag and drop it in. Now, when we're back in VS Code, we see we have a underscore process dataset.ipynb. I'm going to open this Jupyter file and it has steps and instructions. So this is installation if you do not have these packages ready. I'm going to import these libraries and then we have to define our root folders. It also tells us that the image will be resized with a height of 64 by a width of 64 because we have mentioned that it is 64 by 64. My data set is called fruit data set. So I'm going to rename this to fruit data set. And I want the process data set to be called process fruit data set. So I'm going to add more. I want it to be 64 by 64. That's fine. This is to clear the previous process fruit data set if it exists, so that it overwrites everything. And then it will go through everything inside of that folder, check if it is an image, and then it will load the image and perform a resizing, a denoising, and a grayscale if you want it. Let's say I want my grayscale for this one. All I have to do is to remove that hashtag sign. This will perform my pre-processing. It means that all of my images will be resized, they will be denoised, and that they will all be gray. I'm going to play this. I'm going to select Python 3.9.9. And now I have a new data set that is processed. So the apple, when I select an apple, I can see it is gray and it has a height and a width of 64 by 64. So this is my process through data set. Now I realize I don't have enough images. I want to augment them. So I'm going to go to code and I'm going to get the augmentation file, b underscore augmentation.ipynb. I'm going to download it. And I see it in my downloads, so I'm going to drag it to my workspace folder. When we go back to Visual Studio, we can see that we have b underscore augmentation.ipynb. It also has an installation. If you don't have augmentations, all you have to do is play them and it will create new images for you. So I'm going to play the first one, select the kernel. It has ticked, so it's okay. The second part is to define the root folders. My root folder is called process fruit dataset, and I want the augmented dataset to be called augmented fruit dataset. So I have confirmed this. This variable will be used to count how many images were successfully augmented. I have created my transformation. I have composed with a horizontal flip, random brightness, a rotation, and a random crop. My images are already 64 by 64. So let's say I want to randomly crop them 32 to 32 just to see what would happen. If you need more transformations, you can go to augmentations.ai, docs, 3 basic usage, and then choose augmentation. This will give you more augmentation that you can add inside of your pipeline. Okay, so this is the same code as before. It will delete the augmented data set if it already exists. And the same loop, it will check if the image, if it is an image, use CV2 to load the file, apply our transformation, and then finally save the file. Now here I have specifically stated that the file should start with AUG underscore file name. This will give you a new file name so that you can tell that this image was not the original one. This is the augmented version of that image. Now, similarly, all I have to do is click on play. So I'm going to play this one. It says transform A is not defined. Okay, I think we have to import it. Let me write import augmentations as, wait, oh, it is imported, sorry. Let me play it again. I don't, oh, it did not play. Okay, let's play this one. Okay, so it was not played correctly. It's fine. So I have made the transform, and now it has finished augmenting 275 images. So you had 275 images, now you have another 275 images inside of your augmented fruit data set. So now you have apple, which is gray. If we scroll down to augmented apple 1, we can see that something about it has changed. So all of these augmented images are not like the original, they're a little bit different. They have been either recropped or they have been sort of brightness changed with their contrast. Something has happened to them that makes them a new image. So this is data augmentation. You can use these scripts on any other data set that you like. I suggest that you practice with other data sets and see what happens. Change the parameters, especially the resize widths over here, and as well as the composition of these, change the p variables as well to see what happens. You can add more transformations inside of your pipeline. If you are stuck anywhere, let me know and I will sort you out.